Okay, so for our first example from 1.4, we're going to go through number 2 from the homework. So just because this one gives us a chance to practice finding tangent line equations for graphs. So you'll notice we're given a function, and we're given the specific point that we're going to find the tangent line at. So that, if I think about writing my tangent line, I'm going to write it using point slope form. And if I think about it then, that means I need 3 things. First, I need my x1 and y1. I need my x value, and I need my y value from my point. Where am I going to find that? I'm going to find that right here from the coordinate point it gives me. So that's the easy part. The tough part is I also need to figure out m. How do I figure out m? Well, remember, the slope of the tangent line is the derivative at the specified point. So in order to find m, I need to find the derivative of this function, which means I'm going to do my limit definition of a derivative. So here's my difference quotient. Wait, I put x, but I do have a specific x value, don't I? My specific x value is 4. So I'm going to do f of 4 plus h minus f of 4 all over h. And I can go ahead and start plugging this in. So the first piece, f of 4 plus h. Everywhere I see an x, I'm going to plug in 4 plus h. Next part, f of 4. Well, that's just me plugging in 4 into the function, which I technically already know what that is, right? That's the corresponding output value. But you can double check that just by doing the math. So next, 4 plus h squared gives me 16 plus 8h plus 8 squared. Once again, if you're not sure how I'm getting this, just do the work on your own. 4 plus h times 4 plus h, right? That's 4 plus h squared. And then go ahead and do your foiling. Your outer terms, your inner terms, your first terms, and your last terms. Okay, so there's my f of 4 plus h minus, and then like we said, this one ends up just being negative 49. Okay, I'm going to keep cleaning up that first term, and I'm left with negative 1 minus 48 minus 3 times 8 is 24h minus 3h squared, and then I have a plus 49. What's negative 1 minus 48? I get negative 49. This is equal to negative 49, and then I have a positive 49. So sure enough, everything that doesn't have an h cancels out. That's what we want to happen. That's a good sign. That means we're doing stuff right. So everything that didn't have an h canceled out, and I'm left with negative 24h minus 3h squared all over h. I can factor out an h out of the numerator because everything that's left has an h attached to it. Those h's cancel out, and I'm left with this limit as h approaches 0 of negative 24 minus 3h. What can I do now? I can plug in 0 for h, which causes that term to go to 0. And I'm left with negative 24. What is this negative 24? That's my slope at this specific x value. So the slope of my function is negative 24 at this specific x value. Where do I use that? Remember, this is my m. It's my slope of my tangent line. So now I'm ready to write my equation. I get y minus my y value, which is negative 49, equals my slope, which is negative 24, times x minus my x value, which was just positive 4. So x minus 4. Now you'll notice your homework, you have to actually solve for y. If I clean this up a little bit, minus a negative 49 gives me y plus 49. I can distribute the negative 24. So I get negative 24x plus 96. And then I'll just subtract 49 on both sides. And I'm left with y equals negative 24x plus 47. And there's my answer. There's my tangent line equation. Okay, the next problem we're going to go through is number 6 from your homework. And the reason I picked this one is because this one can get a little bit tricky. But first of all, I want to point out, what are we actually solving for? We're trying to find g prime of t. Notice I don't specify, or this problem doesn't specify a specific t value. It doesn't specify a specific input value, which means I'm really just trying to find the derivative function. So I'm still going to use my limit definition of a derivative, but instead of plugging something in for x or plugging something in for t, I'm just going to leave it. My function is g now, so I'm going to use g. So g of t plus h minus g of t all over h. What does g of t plus h look like? Well, that just means I'm plugging t plus h in wherever I see a t. So I end up with 4 over t plus h squared. What about g of t? G of t is just 4 over t squared. Put that in just straight. So this is where it gets a little tricky. Where do I go from here? Well, we mentioned this way back in 1.1 or maybe 1.2 of we have a few strategies when we're working with limits of how to keep going. And one of the strategies is if you have two different fractions, it might be helpful to combine it into one single fraction. So let's see if we can do that. Let's see if we can combine this into one single fraction. So in order to do that, I need to find a common denominator. So that means this fraction, I'm going to multiply by t squared over t squared. Remember, you have to multiply both the numerator and the denominator by the same thing in order to keep that fraction equivalent. This fraction, I need to multiply by t plus h squared over t plus h squared. So let's see what that gives me. I get this limit as h approaches 0 of 4t squared over t plus h squared times t squared. And then this other fraction, I get 4 times t plus h squared over t plus h squared times t squared. So I now have a common denominator, and I can combine these fractions into one fraction. So that gives me 4t squared minus 4 times t plus h squared all over this common denominator of t plus h squared times t squared. And of course, that's all still over h. Well, by finding a common denominator, I can now focus in on just this part. Can I simplify that piece? Meanwhile, while I'm doing that, since I have a fraction that's just being divided by another number, I can combine these two things into the same denominator. So, in the numerator, I have 4t squared minus 4 times what's t plus h squared? I get t squared plus 2th plus h squared all over. And once again, I can just combine those two denominators. So I get t plus h squared times t squared times h. So now we can distribute this negative 4 to each of these terms. And I'm left with the limit as h approaches 0 of 4t squared minus 4t squared minus 8th minus 4h squared over t plus h squared times t squared times h. And you'll notice 4t squared minus 4t squared. So I have terms that will cancel again. And when those cancel, in the numerator, I now have 8th minus 4h squared over t plus h squared times t squared times h. So you'll notice that the terms that canceled were the terms that didn't have an h in it. So I'm able to factor out an h out of my denominator, just like I was able to in like the example problems we went through in the concept video. So I factor that out, and I'm left with negative 8t minus 4h all over t plus h squared times t squared times h. I can now cancel this h in the numerator out with my h in the denominator, which eliminates my discontinuity. And I'm left with this limit as h approaches 0 of negative 8t minus 4h over t plus h squared times t squared. Now that the h has gone out of the denominator, I can now go ahead and plug in 0 for h. And where does that go? That's going to go right here. So I'm going to plug 0 in right here. And I'm going to plug in 0 right here. So what does that leave me with? That leaves me with negative 8t in the numerator, because the other term just goes to 0, right? 4 times 0 is 0. And then down here, t plus 0 is just t, so I'm left with t squared times t squared. What is that? Well, that's just t to the 4th. And now that my terms are way more simple now, I have a t in the numerator and a t in the denominator. I have 4 t's in the denominator, so I can simplify that as well. And that leaves me with negative 8 over t cubed. And I'm done. Okay, let me know if you have any other questions on these problems or on any of the other problems on the homework. But good luck, and I'll see you in the 1.5 videos.